Mr. Wilson's on the call.
Okay, guys, everyone, like, be quiet for like 2 seconds.
How are you guys doing?
Doing good.
Good.
Mr. Woodward.
You like my horse mask?
We miss you guys so much. I can't tell you. I'm taking a picture of you too. Hold on.
Hold on. Take a picture with my horse mask on. Hold on.
Get one of me right
Oh,
here.
there you go.
It's the official timer in the county.
Xander, that horse mask is fire. Where'd you get
Are
it?
you bringing Mark Drive?
Welcome back, these students. Let's continue with more examples here today. Let's try this problem right here. Now we're going to do equations. So let's try a few problems here, starting with this one. Solve for theta, where theta is between 0 and 360. There are different ways of solving an equation like this. I can think of like 5 or 6 different ways. You ask me, which of all those methods is the easiest? Well, I don't know, because what's easy for you is not easy for the person next to you, perhaps. But here's just one popular traditional way. Think about what this is saying. You know that theta is an angle, like 30 degrees or 150 degrees or 1,000 degrees, something like that. It's an angle. But you have to tell me what that angle is, such that if I go here and I do this, this is what it says. Now recall from yesterday that cosine is the x-coordinate. So what are we looking for? We are looking at the unit circle, and we are looking for points whose x-coordinates say 1/2. So look at your unit circle. There are lots of points here, lots of x-coordinates, lots of y-coordinates. Where on this map do you see an x-coordinate that says 1/2? Well, if you look closely, you see that you have one such location right here. But is there another location? Look all around the map. There should be another one, and it's actually right there. So what exactly do? I give the teacher the locations, the angles where that happened. And where was it again? It happened at 60 degrees, and this one here was at 300 degrees. So for this first problem, we have just discovered that theta equals 60 degrees and theta equals 300 degrees. Done. What about an alternative way of doing the same problem? Here we go. We know from yesterday's facts that cosine of theta can get replaced by x equals 1/2. And so now we have this very simple statement. I am looking at the unit circle for x's that say 1/2. Where did that happen? That happened here, and that happened here. And so, of course, the answers would have been 60 and 300. So you could just turn this into that, or you could look at the original equation, analyze it. I don't care how you do it, just be correct. Another quick comment is the idea of checking your answer. I know that these are legit because if I take 60 and plug it in there, it'll say cosine 60. And if you type this into your Casio or on Desmos, do you know what it's going to say? It's going to say 1/2. If I take 300 and plug it in right there, you know what cosine 300 is on your Casio? Assuming that your Casio is set to degrees and not radians, it'll say 1/2. So that's one way to check your answers, just as a quick FYI. Notice that our answers were answers that were between what and what? They were between 0 and 360, as is required. Let's do a little bit of prep work. Why don't we add this to this side? So we have 2 sine of theta equals square root 3. Then why don't I divide both sides by 2 so that sine of theta equals square root of 3 over 2. Now what is the goal? I remind you the goal is to find theta. That's the goal. You tell me what theta is such that the sine of that theta is this. Now recall, folks, that sine of theta is y. So now you're looking at the unit circle, but now you're looking at all of the y-coordinates. And what is it that you want the y-coordinate to be? I want the y-coordinate to be this number. Where do you see that number for y? I see one location there, and I see another location here. Sometimes there's one answer. Sometimes there's 2. Sometimes there's a billion answers. You never really know. So those 2 angles were 60 degrees, and the other one was 120 degrees. Done. A couple more problems and then we're done. So try the next one that looks like this. So now we have secant of theta. Now recall that secant is the same as 1 over x. So if you want, this can be replaced by 1 over x equals -2 square root 3 over 3. You know what I don't like about this? I don't like how it says 1 over x. I really wish that this was flipped. So what I'm going to do is I'm going to flip this side, but I'm also going to flip this side. On a Casio, type this in. This can actually be simplified, and it does get simplified to become this. So this is what we have, but this is not the answer, guys, because the answer or the goal was to find theta. This is a statement that's going to help you to discover the values of theta. So now this is when you go to the unit circle. Where do you see an x coordinate that says this? Well, I see an x coordinate that says that right here, and I see another such location right there. And what were those angles? 150 and 210. So theta equals 150 or theta equals 210. One more, guys, and we're done for today. Cotangent minus 1 equals 0. So again, a lot of times these equations require a little bit of quick preparation. So we have cotangent theta equals 1. Now recall from yesterday that cotangent is x coordinate over y coordinate. X over y equals 1. Now this is a matter of interpretation. Guys, don't be a robot. Be a human being and think about what this is saying. What is this saying? This is saying x coordinate divided by y coordinate equals 1. Where do I go so that that happens? For instance, if I go here, if I go this divided by that, is that 1? Of course not, because these are not the same number. And if you divide numbers that are not the same number, it's not going to be 1. So I think I can convince you guys just by simply looking at this that this pair works, because x divided by y. If I go this x coordinate divided by that y coordinate, it's going to be 1. Why? Because they're the same number. So I know for sure that this location is A-OK. This location, no good. This location, no good, because 0 divided by 1 is not 1. No. Does this one work? No, because if you divide this by that, you get -1. And I'm not trying to play with -1. I'm trying to play with +1. So if you look at all the cases, this one works, but also this one, because they're both negative and the negatives divide each other away to become positive. So what were the angles? 45 degrees and 225 degrees. And before I let you guys go, it's actually my niece's birthday today. She turns 14, and I have her gift ready, and I can't wait to present it to her. So let me show you what her gift is. You see, all this set, this is her gift. Now you guys can't tell her. Don't tell her, and I'm not telling you either, but I'm just showing you that this is her gift, and I'm probably gonna tweet it later tonight. I'll probably tweet later tonight what's in these boxes, but I ain't gonna tell you. But I'll just say this, bro. She gonna lose her you-know-what when she sees what's in these boxes, believe that. Now check these out. I have 1, 2, 3, 4, 5, 6, 7. So anyways, I just thought I'd just flex on you guys a little bit. Go to your exit ticket, try it, and tomorrow we'll do more math.